Chapter 4 in the Glencoe book, Section 4.1, Force and Motion. So a force is a push or a pull. A force causes objects to speed up or to slow down or to change direction. Force is a vector. And a vector means it has magnitude, that's like how much, 15 newtons, and a force has direction. So this arrow can be a vector that represents 15 newtons to the right. A force causes an acceleration. So some different types of forces. There's a contact force, where it must be touching the object. There's a field force, which is exerted without contact. So what's that? Well, that's like a gravitational force field, or a magnetic force field, or an electrical force field. If we look at these forces on this book, we have the agent and the system. So let's look at Newton's second law in words, and then I'll show you the formula again. The acceleration of an object is equal to the sum of the forces acting on the object divided by the mass of the object. Much more easily understood, the acceleration A is equal to the net force, I'll explain that some more in a moment, over m. Think about net as the force that is going to cause that mass to accelerate. So Newton's second law, if we spell it out, acceleration equals net force over mass. And again, there's your new equation. You can add this to your blue equation sheet. You're going to be adding things in this section. If we need to rearrange this, we can take F over m and rearrange it. I tend to remember it as F equals ma. The units, mass has to be in kilograms, your acceleration must be in meters per second squared, and that's going to give you a Newton. Now some other forces. We have a frictional force. If you've ever worn climbing shoes, you know how sticky they are. We have a normal force. And a normal force is a contact force exerted by the object, and it's always perpendicular to the surface. So a box is sitting on the floor. The normal force is the force of the floor perpendicular to the object. There's a spring force. That's a restoring force. It's a push or a pull of a spring. And we have a tension force. And that's just the pull exerted by a string or a cable or a rope. Gravitational force, oops, there's our picture. Gravitational force is also known as weight. And weight is Fg is equal to your mass times the acceleration due to gravity. So if I'm 50 kilograms and I'm determining my weight, if I multiply that by 9.8 meters per second squared, I believe I get 490 newtons. So that's my weight in newtons. That's it. We'll work some more on this tomorrow.